Okay. For example, let us take two matrices. Okay, let us say A1 and A2. These are the two matrices. If I want to multiply these two matrices, what are the first condition is? For example, the dimension of the first matrix is 2 cross 3, and the dimension of the second matrix is 3 cross 2, and then this two values should be same, then only I can able to do the matrix multiplication, which means this is the row value, this is the column value, this is the row value, this is the column value. So what you can understand, the column of the first matrix and the row of the second matrix should be same, then only I can able to multiply two matrix. This is the first condition. Okay, so the row, the column and the row should be same. Okay, and then what is the second thing we are going to say here is, if I want to multiply this two matrix, what is the cost of multiplying this two matrix? What does the cost means? How many number of multiplication is required to multiply this two matrix? Okay, that is what the cost of this matrix, which means, how will I say, if I want to multiply this two matrix, how many number of multiplication I required is, you take this 2 into, like, then among this two, this column and this row, both are same, right? So you have to take one among that. So both are 3 only. So I'm going to take only 1, 3 into, then this 2. So let us say this is D0, D1, D2, D3. Or you can say this both are same. So I can say this also as D1, this is D2. So how will I multiply? D0, D1, D2. Right? So when I multiply this, I'll get 2 3s are 6, 6 2s are 12. So I want 12 multiplication to multiply this two matrix A1 and A2. So this is what the cost of multiplying A1 and A2, right? Okay. So what is the third thing we can understand from this? When I multiply this two matrix, the resultant matrix size, what is the size of the resultant matrix? This one, this value and this value. That is the outcome of the resultant matrix. That is the size of the resultant matrix, which means 2 cross 2. Okay, these things you should remember. So, what are the things you have to remember? First thing is, if you want to multiply two matrix, this column and this row should be same. Second thing is, we want to know, if I want to multiply this two matrix, A1 and A2, what is the cost? This is what the cost. What is the cost to do multiplication of this two matrix? So that we'll take this D0, D1, both are same. So we'll take one, D0, D1 and D2. So when you multiply, you'll get the cost is 12, which means the number of multiplication required. And when I multiply this two matrix A1 and A2, what is the resultant matrix? So I have to take this row and this column, the last. So that will give you the resultant matrix size. Let's see an example. For this, for example, I said first matrix, this A1. This A1 matrix is of size 2 cross 3. What does 2 cross 3 means? 2 rows and 3 columns. Say, for example, 2, 1, 3, 2, 1, 1, sum. So 2 rows are there. So you can see 2 rows are there, 3 columns. 1, 2, 3, 3 columns are here. Okay, so this is the matrix A1. And the second matrix A2. What is the condition of second matrix? Is the row, the column here and the row here should be same. So I should have 3 rows. So let it be like 1, 2, 3, and the column should be 2. So 4, 2, 1. So this is what 2 cross 3 matrix, and this is what 3 rows and 2 columns. So I can able to multiply this two matrix. So if I multiply this two matrix, how will I get it? How will I do the multiplication? You know this, right? This row and this column will be multiplied, and this row and this column will be multiplied. So how it will come? 2 into 1 plus 3 into 2 plus 1 into 3. Similarly, 2 into 4 plus 3 into 2 plus 1 into 1. Likewise, here also you will get 1 into 1 plus 2 into 2 plus 1 into 3. And here 1 into 4 plus 2 into 2 plus 1 into 1. So this is what the resultant matrix. So as we saw here in this, you can see that you can count the multiplication 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So as we saw here, 12 multiplication we got, right? And then we saw what is the resultant matrix size? 2 cross 2. So which means we can see here 2 rows is here. This is the first row and this is the second row. So you can see this is the first row, right? So here you can say this is the first row. So this is the first row, and here this is the second row, and here this is the first column, this is the first column, and this is the second column. So 2 rows and 2 columns. So this is what the basic thing you should know about when we multiply 2 matrix. Okay. So here in matrix chain multiplication, the objective is not to multiply the matrix. We want to see what is the cost of multiplying the matrix. So what I already told, cost means what? The number of multiplication required to multiply the matrix. Okay, so already we know if I want to multiply 2 matrix, that is no problem. There is no other solution also. You can directly multiply this, directly we get the answer when there is 2 matrix. And also you have to remember one more thing is, this matrix, sorry, this matrix is matrix multiplication is associative, which means what? I can multiply A cross A2, and it is not commutative. Commutative means what? I cannot do A into A1. So that should be remembered. So this cannot be done. This can be just associative. It is not commutative. Okay, that also you have to remember. Okay, so now let us move to the concept. So if you want to multiply 2 matrix, there is no other choice. Only you have to multiply A1 with A2, right? Now let's go to the other example. Now I have 2 matrices. Let's take A1, A2, and A3. Okay, so now I have 3 matrices. You can assume some size to this matrix as well. Let's say it is like 2 cross 3, 3 cross 4, and 4 cross 2. Okay, so this is what the dimension of this matrix is. So the condition is this value and this value should be same, and for multiplying this 2 matrices, this value and this value should be same. Okay, so we have this 3 matrices. Now whenever you want to multiply matrix at a time, you can multiply only 2 matrix. We cannot multiply 3 matrix at a time. So we can only multiply 2 matrix at a time. So if I have 3 matrix, I have 2 possibility to do this. What are the 2 possibilities? First, I can do like this. I will multiply A1 and A2 first. With the result, I will multiply A3. This is one choice. What is the other choice? I can multiply like this. A2 and A3 will be multiplied. This will be multiplied first, and the result which I get here will be then multiplied with A1. So when I have 3 matrices, I have 2 possibilities to do it, right? Similarly, so now we have to think. So already I told you our objective is not to multiply matrix. Our objective is we have to find which combination or which kind of parenthesis will give you a low cost multiplication. That is what we want to find. So if I multiply in this fashion, will I get low cost? Or will I get in this, if I multiply in this fashion, will I get the low cost? The result which you get out of multiplication will be same for both. The result here and the result you get here will be same. But the number of multiplication required to do this will be different. Okay. So if I have 3 matrices, these are the 2 combinations. Let's take another example. If it is 4 matrix, say for example, if I am taking 4 matrix, then let us see how many number of combinations are there, and I'll tell you how to find the number of combinations. Let's take 4 matrix like A1, A2, A3, and A4. So I have 4 matrix now to do the multiplication. And you know always the dimensions of this matrix, so D0, D1, here D1 and D2, here it should start D2, D3, and here it is D3 and D4. So like this it should be, right? This one and this one should be same. And when I consider these two matrices, this value and this value should be same. And when you consider this two matrix, this value and this value should be same. That is why I have written like this. So okay, this is of the dimension of this one, and this is the dimension of this one, and this is the dimension of this one, and this D3 and D4 are the dimension of A4. So now I have four matrices at a time. So now, as I said earlier, we cannot multiply this four matrix together. At a time, we could able to multiply only two matrix can be multiplied at a time. So now, when I have four matrix, what are the different combinations I can have? So here, I can have five combinations. So for example, I can do like this: A1 into, then A2, and then A3, A4. This is one combination. What does mean? First, A3 and A4 will be multiplied. The result which we get from there will be multiplied with A2, and the result which I get from this together will be multiplied with A1. That is the first combination. And what is the second combination? I can do like this: A1 multiplied with A2, A3, and then with A4. So this is another combination. Okay, so what will you do? A2 and A3 will be multiplied, and then the result will be multiplied with A4, and then the result will be multiplied with A1. So this is another combination. What is the next combination I can have? I can do like this: A1 and A2 will be multiplied, and then A3 and A4 will be multiplied, and then the result of this two can be multiplied. This is the next combination. Okay, these are the different parenthesization I can do. What is the first choice? I can do like this: A1, A1, A2, A3. So this one multiply, and this you will multiply, and then your result multiply. So here we did this time, the result is multiplied with A4, then with A1. Here A2, A3 is done, then that is multiplied with A1, and the result is multiplied with A4. Okay. And the fifth combination, what can I have is like this: A1, A2, this 2 is multiplied, then the result is multiplied with A3, and this result is now multiplied with A4. Okay, so this the 5 combination I can have. So the answer which I get from all this will be same, but what is the difference? The number of multiplication required to multiply is different. So that is whatever cost here. So we want to find the combination, which combination of parentheses will give us the minimum cost, which means less number of multiplication is required. So that what we want to find from all this combination. Okay, so how, for example, here when I take 4 matrix, the number of possibilities is 5. So how will I find it? Actually, we can represent it mathematically. Okay, so whenever you want to find in maths, you might have learned the combinations can be find with a formula like this. What is the formula? 2n combination of C1, Cn divided by n plus 1. So this is the formula to find the combination. Okay. So this is the formula to find the number of possible combination I can have when I have this many matrix. Let us see. And here for this matrix chain multiplication, for the number of matrix n, no, this n you have to take as n minus 1. Don't take as n, we have to take n as n minus 1. So if I change this formula, how will it will come? It will be like 2n minus 1 c n minus 1 divided by n minus 1 plus 1. So this is what I will get, right? So when I change it, this plus 1 and this minus 1 will be removed. So how will I get it? So what can I do here is, this is equal to 2n minus 1 combination n minus 1 divided by n. So this is what the formula to in matrix multiplication to find the combination. This is what we are going to use. Say for example, let us take the n here as 4, right? So n is 4, which means here if you see here we have taken 4 matrices, so the n value is 4. But I said in the formula we have to take the n as n minus 1. So when I apply in this, how will I do it? So we are going to substitute in this formula. So it is like 2 into 4 minus 1 c 4 minus 1 divided by the n is 4. So what will I get? I'll get 2 into 4 minus 1 is 3. Then combination 4 minus 1 is 3 divided by 4. So what will I get? 6 2 3s are 6. C 3 divided by 4. And I hope mathematically you know how to represent this combination, right? It is like 6 into 5 into 4 divided by 4 into 3 into 2, that divided by 4. So this is how we can replace 6C3. So now we can cancel it, like this 4 and this 4 will be cancelled. This 2 and this I'll get 3 and this 3 and this 3 will be cancelled. Somewhere I made mistake. 6, 5, 4. Okay. Okay, I made a mistake. 1 second. So how will you write this 6, 3? Sorry, how will you have, I thought this 3 as 4 and I wrote wrongly. So it will be like 6 into 3, 6 into 5 into 4 divided by 3 into 2 into 1. So this value, 3 times. 3 into 2 into 1 here, 6 into 5 into 1 divided by this 4. So this 4 and this 4 will be cancelled. This 2 goes for 3, this 6 goes for 3 and this 3 and this 3 will be cancelled and you will be getting the answer as 5. So when the n value is 4, which means when I have 4 matrix, the number of combination which we get is 5. Similarly, you can work for some other number also. For example, if you take the n value is 5, so you have to apply it in this formula. So how does it come? 2 into n minus 1. So 5 minus 1 c and 5 minus 1 divided by n. N here is 5. So you will get 2 into 4 c 4 divided by 5. So you will get it as 4 2s are 8 c 4 divided by 5. And how will I write it again? So I can write like 8 into 7 into 6 into 5 divided by 4 into 3 into 2 into 1 divided by 5. And you can solve it and see this 4 will cancel this 2 and so 7 2s are 14. So when you have 5 matrices, then how many number of combination I will get is 14 combinations. So 14 combinations of parentheses I'll get when I have 5 matrices. So you have to know which combination of parentheses will give me less cost, which means less number of multiplication. That is what we want to find. So I hope you might have understood now what is the problem for us. What is the problem here? We have a chain of matrices, and if I want to multiply this chain of matrices, I have different possibility. And among this different possibility, I want to find which is the best, which means what? Which is the optimal solution, which give me less cost. So to solve this matrix chain multiplication, we are going to apply the method called dynamic programming. Okay, we are going to apply dynamic programming to solve this problem. What is my problem? The problem is to find less cost to do the matrix chain multiplication. So you might have already know what is the greedy method, right? What does greedy method will do? Greedy method is also to find the optimal solution, but it will take local optimal to find the global optimal. But what is dynamic programming? Dynamic programming is also a method to find the optimal solution. But here it is not going to take only one decision. It will be taking the result of all possible parenthesization, and then among that it will choose the best. So that is what I have already told in the previous class. This matrix chain multiplication is going to use which method? Anyone remember what is the method I taught you this matrix chain multiplication is using? What is the method used by matrix chain? What is the dynamic programming using? Which method is used by dynamic programming? Which method is used? Principle of optimality, right? What is principle of optimality? Principle of optimality means we are going to not.
Sequence.
Yes, yes, ma. Good. Very good, ma. Principle of optimality is used. What is principle of optimality? Thank you, ma, for your answer. Good, excellent. What is principle of optimality? It is not. Can someone answer?
Sequence of decisions.
Yes, excellent, ma. Very good. So it is not taking decision by seeing only one step. It is going to take sequence of decisions. So here in dynamic programming, it is going to see all possible solution, and from the all possible solution, it is going to choose the best. Okay, so that is what we are dynamic programming is going to do. Let's see how this dynamic programming is going to solve this matrix chain multiplication with an example so that you will understand it clearly. So here for this example, let us take an example. Okay. So to make you to understand, I'm going to take three matrix. So if you have three matrix, how many number of possibilities there? Two kind of parenthesization can be done when we have three matrix. So we are going to take three matrix and we are going to solve this. So let us take the three matrices A1, A2, A3. So these are the three matrices I am going to take. So when I have this three matrix, I have two different possibility of parenthesization. What are the two different possibilities? One is when I take A1, A2, A3, I can do parenthesis like this. One is I can do multiplying this two first, then I can multiply the result with this. This is one possible way. What is the another possible way is, first I will multiply A2 with A3, then the result will be multiplied with A1. So when I have three matrix, the possible combination of parentheses is only two, right? So these are the two possible. No other possible parenthesization I can do here. So these are the two ways. So now what is our objective? We want to find among these two who is going to give us less cost in multiplication. The cost here is number of multiplication required. So let us assume some dimension for all these matrices. Okay, dimension means how many number of rows and columns for each matrix. Let us assume the dimension of first matrix is 2 cross 3, then it is 3 cross 4, and it is 4 cross 2. Okay, so let us take this is the dimension of this matrix. And the same thing here also. Same matrix, only here also we are going to take 2 cross 3, 3 cross 4, and it is 4 cross 2. So if you take here, you can clearly say this value and this value should be same, and this value and this value should be same. Let us give some name to this dimensions. So what is the dimension of A1 matrix? The dimension of A1 matrix is 2 cross 3. The dimension of A2 matrix is 3 cross 4. The dimension of A3 matrix is 4 cross 2. Okay, so you have the same for your lab exercise also. So please listen carefully. If you understand it, it is very easy. Okay, it is very, very easy only, but you just listen it. If you listen it, it is very easy. Okay, so for the dimension, let us give some value to the number, some name to the dimension. Let us say this is dimension D0, D1, and again this both should be same, right? So again I'll give the same name D1, and it is different D2, and this dimension and this dimension should be same. So I'll take the name as here also D2, and this dimension is D3. Same thing here also. I'll say this is D0, D1, and here this also D1, because this column and this row should be same. So for both of them, we are going to give the same name D1. And again here is D2, here also D2, and here it is D3. Okay, so these are the dimensions. So now we are going to see what is the next step. So now first let us multiply this side. Okay, first this part we'll do, then we'll do the second part. So when I do multiplying this two, so first I have to multiply this, right? I have to multiply this, and that result I have to multiply with this part. So when I multiply this, how will I multiply? Already I have taught you. If you want to find the cost of multiplying two matrix, how will you find it? This is the cost, right? How to find? We have to take the row, and from this you have to take any one value because this column and row are same. And then here you have to take the column, right? So I'll take 2 cross 3 cross 2. Okay, I hope you're all listening. Please don't play. It is a very important problem, and for your exam perspective, for your lab perspective, everywhere it is important. I hope that you're not playing at your hostel room. I hope you're all listening. I'll ask question at the last, okay? I'll call you by name and I'll ask. So please don't play. So now you know how to find the cost. How will you find the cost? This row into, from this you have to take any one, and from this. So 2 into 3 into 2. So similarly, if you say for here, so how will I find the cost? So I have to multiply as 2 into, from this 2. From this 2 I have to take 1. So 2 into 3 into 4. So this is what the cost of multiplying A1 and A2. So which is 4 threes are 12, or you can say 2 threes are 6, 6 fours are 24. So if I want to multiply this, the cost of multiplying these two matrices is 24. Then plus, now in this step we didn't multiply A3 with anyone, right? So now in this step, the cost of multiplying A3 is 0 because we don't do any multiplication. So I hope you got it. So first we multiplied A1 and A2. When I want to multiply A1 and A2, the cost is 2 into, from this 1. So 2 into 3 into 4. So 24. And then this A3 we didn't do any multiplication. So the cost is 0. So this is one step. Then after finding this, after multiplying A1 and A2, what is the size of the resultant matrix? Sam, can you tell me what is the size of resultant matrix? When I multiply A1 and A2, what is the size of resultant matrix? Sam Chandra? Sam? So absent. Sam is not there. Sam?
Yes, ma'am.
Hope you are listening. Can you tell me, ma, what is the size of the resultant matrix when I multiply A1 and A2? So A1 is a matrix, A2 is a matrix, right? When I multiply this A1 matrix with A2, what will be the size of the resultant matrix?
20.
20. Sam, where are you at present? Okay, please listen, Sam. So when I multiply these two matrices, the resultant matrix size is, how will I find? I said 2 and 4. That is what initially I taught you, right? Cost, when I multiply this two, the resultant size is 2 cross 2. This means this value and this value you have to take. Okay, so I hope I know that you're not listening. So if I multiply this two, I have to the resultant matrix is this value and this value. So what will I get here? 2. The resultant matrix size is 2 cross 4. So now this need to be multiplied with which matrix? A3 matrix. What is the size of A3 matrix? This is resultant matrix. Okay, this is resultant matrix. Now this matrix need to be, with this resultant matrix, I want to multiply this A3 matrix. The size of A3 matrix is 4 cross 2. Now I want to multiply this two matrix. So again we want to find the cost of multiplying this two matrix. So before I do it, let me give the dimension names. So here for every dimension, for A1 matrix the dimension is 2 cross 3. For A2 matrix the dimension is 3 cross 4. For A3 matrix the dimension is 4 cross 2. So for every dimension we have given some name, right? So let us give the name here also. That will help you in future. So let me give some name. What is the value? What is 2? 2 is D0. What is 4? 4 is D2. What is this 4? This 4 is D2. What is this 2? This 2 is D3, right? So let me write it. This is D0. This 4 I got because of D2. This 4 is D2 and this 2 is D3. Okay, so this is what the dimension. So now this is one matrix and this is the another matrix. Now we want to multiply this two matrix. If I want to multiply this two matrix, you know how what is the cost or the number of multiplication required is you have to take this value. From this 2 4s, I will take any one 4 and then we have to do this, right? So what will you do? 2 into 4 into 2. So what will you get? 4 2s are 8, 8 2s are 16. So this is what the cost, okay? So what is the, again, we'll give some name to this. So what is the name? For this 2's name is D0 and this is D2 and this is D3, right? So this 2 I get from this and this 4 I got from this 2 4. Both of them's name is D2 and this 2 I got from here, that's own name is D3. So that is what here I have taken. And finally, the cost of multiplying the resultant matrix with this A3 matrix is 16. So if I want to totally find the cost, what is the cost? 24 plus 0 plus 16. What is the answer for this? What is the answer to multiply this two? When I add all this thing, what is the answer?
40.
40. Good motive. You're all listening. Good. God bless you. Okay, so now this is the cost of multiplying this two matrix when I do parallelization in this method. Okay. So before I proceed this, before you forget all these things, I'll do some more operations here. Okay, so what we did first, first what we did, first we multiplied this A1 matrix with A2. Objective is what? Objective is to find the cost. So cost means what? The number of multiplication required. So we have to see how we did the multiplication. So first we multiplied these two matrices A1 and A2. So first matrix we did multiplication is A1 and A2. So first we found the cost of multiplying the matrix. I'll write it in another color. Which color I'll take green color. Okay. So first I found the cost of multiplying matrix 1, 2, right? That's what we wrote. First we multiplied this two matrix and for this multiplying this two matrix, the cost is represented as 1, 2, right? Then what I did plus 0 plus what is this 0? This 0 represents this matrix, that is matrix 3. So multiplying the matrix 3 is 0. So how will I represent that? The cost of multiplying this matrix 3 is 0. So I'll say cost of multiplying 3, 3 because we are not multiplying that with any one, right? So that is what we are finding. So first step we did it. This is what the first step we did. So first we multiplied A1 and A2. So for that it is represented as cost of 1, 2. So that is what we are finding here. That is what we are finding in this place. Right? In this place, we are finding 2 into 3 into 4. What does that represent? The cost of multiplying this two matrix. After that, this is added with this matrix. To multiply that matrix, it is only one matrix, so the cost is 0. So this is what represent using this, right? Then, so here we got the answer as 24. After that, what we did is, after multiplying this, we got a resultant matrix. This is what the resultant matrix we got. That is 2 cross 4. Okay. So this is what 2 cross 4, which is the resultant matrix. That is multiplied with the matrix A3. What is the dimension of A3? 4 cross 2. So that is 4 cross 2. Okay. So now when I finally multiply this to, which means if I want to find the cost, we know how will we take this 2 into 4 into 2. So which means it is D0 into D2 into D3, which means we'll take this 2. Okay, we'll take this 2. So we took this 2, and from this 2, this 4, we took only 1, and then we took this 2. So this is what the cost. So it is denoted by D0, D2, D3. So when I find the total cost, how I found? The cost of multiplying A1 and A2, the cost of multiplying 3, 3, plus, see here we see, then we did a plus. And what is the answer of 16? How we got 16? 16 is by multiplying all these 3 things. We got 16 because of multiplying these 3 things, right? So now we are going to write it as a equation. How we multiply this 3 matrix? How will I write totally? It is very easy. How I wrote, I can write as the cost of, I'll take this, the cost of multiplying the matrices, which 3 matrix, 1, 3. Okay, the 3 matrices, how we did is, first we find the cost of multiplying 1 and 2 matrix plus cost of multiplying 3, 3 matrix plus D0 into D2 into D3. So this is what finally we got the answer. This is how we got the answer as 40. So from this total answer only we got here as 40. When we add this with this with this, finally we got 40. How many of you understand this equation? Can I get the hand raise? If you understand this, half of you understood this problem. How many of you got how this equation came? None of you understood. Tracy. Okay, Jonathan. Kevin, good ma. I hope you really understood it, right? Yeah, thank you for your hand raise. I hope you got it. I'll just tell you how you got the cost. Cost means multiplying together. Yeah, thank you all okay, thank you for your response, ma. So, listen, ma. The objective is we want to see when I multiply these 3 matrices, what is the total cost? That is what we want to find, right? So what we did, first we multiplied this 2, and the result was multiplied with this. So that is what we did. Actually, that is what represented here. So first we found the cost of this, and then that is added with the cost of this, right? So that is what first we multiplied this 2 matrix, and then we just kept as it is. So cost of 3, 3, that is 0. Then from this we got a resultant matrix 2 cross 4. From this 2 cross 4, we multiplied it with the A3. A3's dimension is this. And then this number's name already we have given, that is represented here. So totally, if I want to find the total cost, which are the things I have to consider? I have to consider this value, and finally this value. So that is what represented using this equation. So that is what represented in this equation. Okay, so I have this one, and finally this value. That is what together we got the result. Okay, so let us keep it aside. We'll do the same thing once again for this type of parenthesis also. So when I do it once again, you will definitely understand clearly. I'll do it. Okay. So first here, what I have to do, first I have to, in this side, first I have to finish A2 and A3 first, right? So I have to find the cost of this. So which means cost of multiplying 2, 3, that should be added with cost of 1, 1. So how will I find the cost of 2, 3? It is by 3 into 4 into 2, right? 4 3s are 12, 12 2s are 24, right? And then for multiplying the matrix 1 alone, it is 0. That is done. So first step is over. First we multiplied this, the result we added with A1. So 0 plus this, we got the cost. After that, after we multiply A1 and A2, we will be getting a resultant matrix, right? So what will I get? The resultant matrix we'll get is 3 cross 2. So this value and this value. So this is what the resultant matrix. Okay. And what is this dimension? This is D1. This is D3. And now we want to multiply this with A1 matrix. What is the size of A1 matrix? 2 cross 3. And its dimension is D0 and D1. So now we want to multiply, and the condition is also satisfied. This value and this value is same. So when I want to multiply these two matrices, so what is the cost? 2 into 3 into 2. So what is this 2? It is D0, this is D1, and this is D3. So if I, so what is the answer of multiplying these three things? 2 3s are 6, 6 2s are 12. So if I want to finally find the total cost, I have to add 24 plus 12, right? I have to find 24 plus this 12. So what is this 24? 24 is this. And what is this 12? 12 is this three values. So if I write it again together, same thing you will get. If I write it together, how will I write? I can write it as cost of, same thing I am going to write, plus cost of 2, 3 plus D0 into D1 into D3. Totally, what will you get? 24 plus 12. What is 24 plus 12? 36. Right? So now here itself you can understand. In the first method, the cost is 40. In the second method, the cost is 36. So here itself we can see there is some difference. So if you multiply in this fashion, when I make the parenthesis in this fashion, the cost is 36. When I do the multiplication parenthesis, when I keep the parenthesis in this fashion, the cost is 40. So from here itself you can understand there is a difference. So when I have a huge number of matrices with different very big size of dimensions, there when I do concentrate on it, we can reduce the lot of cost, which means the lot of multiplication can be reduced if you find the best. So here dynamic programming means what I said, we have to see all possibilities, and from that we have to choose the best. Okay, so now when I multiply three matrices, these are the two different way I can find do the multiplication, and we find the cost of doing in the two method, right? So from this formula we can understand something that I finish it. With that I'll finish it. After that you have to do one quiz, and then you can leave. Otherwise I think it's time, right? I'll give you a quiz. So the remaining how we can understand from this formula we'll discuss in the next class. Okay. I hope you got it. How many of you got it until this? Yes. Thank you, ma.
Thank you, ma'am.
Okay, God bless you, ma. And don't leave. Thank you, ma. Thanks.